À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain, allumage des EAP et décollage.
Lights up first, computers check out for 7 seconds all the pressure, testing it on the ground, and then the boosters go. We'll let the DDO, we'll call out the final countdown and be back after Ariane has cleared the tower.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top, allumage Vulcain. Confirmé. Top, allumage EAP, décollage. Les paramètres à bord sont normaux.
Beautiful there, Ariane off on her way with just a 24-hour delay, leaving a trail of gold as she rises into the sky over French Guiana at 18:51 local time and right on time. Ariane began.
Then a gyro ignition of the Vulcan 2, followed by verifications and liftoff with ignition of the SOBs.
Attention pour le décollage. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top, allumage Vulcain. Allumage confirmé. Top, allumage EAP, décollage. Tous les paramètres à bord sont nominaux.
Well, we lost her to the low clouds early, but in a blaze of light, there she is coming back out of the clouds, roaring off the pad. The DDO says everything is normal, propulsion and trajectory. In a blaze of light and a trail of gold as Ariane 5 reaches into the skies above French Guiana on her way to deliver ATV-3, which will make her way to the International Space Station next week.
We've lost her through the clouds. So the launch vehicle first clears the pad in a vertical rise. And you can start hearing the noise. And the launch
final countdown. Enjoy the launch, everybody.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage EAP, décollage. Tous les paramètres à bord sont nominaux.
And so we are underway. Did you see at 18:52 local time and right on time, Ariane 5 began her mission, lifting off beautifully, showing a lot of power right from the ground here in French Guiana with a lot of fire, beginning her second mission of the year, the 2010 ATV.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain, allumage des deux EAP et décollage. les paramètres à bord sont normaux. Les paramètres à bord sont normaux, la propulsion est nominale.
And we're off. Ariane 5, powering.
Friday morning, around 36 hours ago, the launch vehicle is sitting on its launch table and is towed by a truck from the final assembly building where the ATV was mated on the launch vehicle up to the launch pad some 4 kilometers away.
Takes about an hour to roll out there because the trucks, special trucks, roll out very slowly.
A very special truck indeed, capable of towing the equivalent of almost 3 Airbus A380 at full charge, but very low speed.
Can you give us a very quick explanation of the green status panels where everything is smooth?
So this, yes, this panel is the status of the different systems which are all involved in the synchronous sequence, and for which they have to be ready at the same time, at the same moment, to allow the launch.
And these include the launch base, the launcher, the satellites, in this case the ATV, Jules Verne. Basically all the systems across this very big space base, Europe's spaceport, all these systems summarized by the green status panels coming into Jupiter here, which is why we call Jupiter the nerve center of the whole thing. The DDO, Thierry Vallée, again, you'll hear him call out the 1 minute mark in just a moment, and we'll be into the final 60 seconds.
À tous de DDO, attention pour moins 1 minute.
Are you going to go out and see the show?
I go and see the show.
Alex is going to step outside.
Top H0 moins 1 minute.
See you later. Alex is going out to the terrace. There are 2 terraces on either side of us here. The folks, the invited guests, are going out now. And he's going to watch the launch and come back, and he'll give us his impressions live. In the meantime, keep your eyes open for the final ignition sequence. You will hear the DDO call out 3, 2, 1 ignition. And you'll see the main engine light up. And then count to 7, because during those 7 seconds, the computers that we've been talking about will be checking out pressure and temperature. And if they find everything all right, then they'll give the order to light the boosters. Those are the ones on the side there. And then we'll be off. So we'll let the DDO call out the final 10 seconds, and we'll let you enjoy the liftoff. And we'll be back with you after Ariane has cleared the tower.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain, allumage des EAP et décollage.
The night sky over Kourou here, always an impressive sight. 775 tons lifting off. The DDO is saying that everything is okay on board. Alex has just come rushing in. You look very pleased of what you've seen. How was it out there?
That was absolutely terrific. It was a marvelous show. The light and sound were absolutely impressive.
What impressed you most?
I think the sound, but it comes a little bit later, but the sound is really impressive.
It's not the first time you've seen a launch.
No, it's not the first time, but each time it's a little bit like the first time.
All right, sounds exciting. I'll go out next time.
So we are now in flight. So from now on, we shall leave the green panel and follow the launcher's health status on this little graphic that you can see.
On the upper are all the checks that take Ariane down to liftoff, not beyond. Is that right?
Yes, they monitor all what's happening on the launcher and all the information coming from the different checks.
Now, how many people are up there? I know there are 3 teams. How many people?
Around 150 people, maybe 200, including all the people in charge of the ground installations maintenance.
I think there are 3 teams basically up there, coordinating the campaign and the countdown, guaranteeing flight readiness.
Yeah, there may be even 2 teams preparing for 2 different launch campaigns, because we can prepare our launcher for the next flight, and while being about to to finish the campaign of the previous one.
All that taking place about 14 kilometers away from here, where we are in Jupiter. You can see Ariane on the pad. Coming up on 2 minutes, we're still green. That's the color we want.
Green, which is very good news.
What's happening now?
Now, what's happening is that we have the very last operation on the launch vehicle, which will progressively become totally autonomous from the ground systems.
This is what basically happens during the synchronized sequence from the 7 minutes down to liftoff is power. Am I right in saying power passes from the ground control over to autonomous onboard computer control?
Absolutely.
Okay, so that is what's happening now. If we bring the camera back into Jupiter, you'll see people starting to wander out onto the terraces. There they are. They're going out. There are 2 terraces on either side of us here, observation decks, and the VIPs and invited guests go out there usually about this time, and they have a bird's eye view of the launcher lifting off, passing right over our heads on her way. The DDO will call out the 1 minute mark in just a moment, and we'll be into the final 60 seconds of Flight 200.
Le DDO. Attention pour H0 moins 1 minute. Top H0 moins 1 minute.
All right, we're into the final 60 seconds of the first launch of the year. Remember, you can follow all the action on the website. You have the address right there. The ignition sequence, tell us about that, Alex. You'll hear the DDO call out allumage,
yes,
which is ignition.
You'll see the flame under the main engine, Vulcan. So we shall ignite the engine and check it for 7 seconds.
That's the main engine.
That's the main engine. And when everything's fine and with the check is okay, then the ignition of the boosters and the actual liftoff.
Okay, so you get main engine lights up first, computers check out for 7 seconds, all the pressure, testing it on the ground, and then the boosters go. We'll let the DDO, we'll call out the final countdown, and be back after Ariane has cleared the tower.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité. Top, allumage Vulcain. Confirmé. Top, allumage EAP, décollage. Les paramètres à bord sont normaux.
Beautiful there. Ariane off on her way with just a 24-hour delay, leaving a trail of gold as she rises into the sky over French Guiana at 18:51 local time and right on time. Ariane began her mission.
And right on time. So we had a mass at liftoff of 773 tons, including 554 tons for the sole boosters. The boosters which give a very strong initial acceleration that will increase velocity from 0 to 7,200 kilometers per hour in about 2.3 minutes. That's 4,500 miles per hour. So after booster separation, which will occur in about 2 minutes, the launcher will have lost about 75% of its liftoff mass. The boosters will fall down into the Atlantic Ocean in a zone which has been secured by an international advice to maritime navigation.
Ariane burning now 5 tons of fuel per second. That's 2.5 tons in each booster per second. The EPC, also the core stage, as it's called, is burning another 300 kilos of fuel per second. All that adds up to roughly the equivalent of a dozen Airbuses. She's now following the program in the onboard computer, which gives all the orders, including stage separations, which we will soon see. 4 powered flight phases tonight. We're in the first one, the main engine and the boosters. And the boosters, as Alex said, they're going to burn for another maybe 20 seconds. Alex, take a look on the left, the upper left screen. Can you give us a description of the curve, please?
Yeah, we see the simulated flight trajectory, which is computed by using very accurate mathematical models of the launcher and the ATV, and by application, of course, of the Keplerian laws for the ballistic phase.
Which we're going to hear about a little later.
Yeah, a little later.
All 3 of them.
So the Mach, which follows...
DDO has just called out the separation of the boosters. You can see what that looks like. There's another one out of camera range on the left, but they fall back down right on time at about 64 kilometers up, I think. They fall away from the shore. People streaming back in from the terraces you can see in the background there.
Yes, now to follow the actual flight. And now we're expecting the fairing separation.
That's the next milestone.
Minutes.
You can see the cursor crawling up on the upper left. I don't know if you can read it. Sep coif. It says separation of the fairing. On the lower left, Alex, can you describe what the bottom lines are?
Yes, we have the real-time information from the launcher of the velocity and the altitude, and also the angle of the telemetry antenna with respect to horizontal.
So you see the altitude. The altitude is 102 kilometers. That's the second line. So we're above the atmosphere, which is where we can separate the fairing, and the DDO will call out that milestone in a moment. We are in the second.
Largage de la coiffe.
There it is. Largage
there
de la
it
coiffe.
is. So we don't need the protection of the fairing anymore. We have crossed the atmospheric layers, and then now we don't need this 2 tons weight anymore.
There are actually two halves. One half, like one of the boosters before, was out of
this cut vertically and
range.
horizontally.
Everything is perfect on board, says the DDO. The ATV now under the fairing, exposed to the elements. And we're going to go now to the next part of the broadcast, which is the latest news from Arianespace, and there is a lot of it. So take a look. Ariane ended 2010 in style with its 6th successful launch on December 29th, delivering 2 telecommunication satellites, Hispasat-1E for Spain and KoreaSat-6 for South Korea. It was the 41st straight lightning. Ariane can fly in the rain, which is not a problem. However, there are certain constraints like lightning.
There are 2 typical constraints. One is speed of the wind, high-speed winds, and the second is lightning criteria. And this is taken into account by avoiding launches close to storms or in certain type of clouds, such as convective clouds, where you might have lightning.
Back in Jupiter, we're going to go to a presentation of the satellite. You look under the fairing there. We showed you close-up of the launcher. That's what things look like underneath the fairing, where you have the very heavy Eduardo Amaldi, going to bring much-needed food, water, and supplies to the ISS and bring down some used items and other garbage which will burn up in the atmosphere.
And a very big spacecraft, as you can see. It's practically the size of a double-decker bus that you'd have in London.
The first of the ATVs to be processed and launched within the target cadence of 1 year. The first 2, I think, missed that. But Eduardo Amaldi doing fine, carrying the largest and most sophisticated flight software ever developed by the European Space Agency. The total mission for this ATV will last 171 days. She'll be docked with the space station for roughly 6 months, which I think was the case for Kepler, the ATV-2. You see these, what look like radio towers, the 4 of them, around the Ariane 5. Those are not radio towers, those are lightning rods, actually, because we mentioned the lightning being a delicate element.
You have to remember that the 2 solid boosters they have 240 tons of powder. So we're very careful with that sort of thing.
Coming up on 2 minutes before Arianespace Flight 205 begins, a moment of, what would you call it? You've been down in the fishbowl more often than I have. A moment of intense concentration, focused at 2 minutes before launch. How would you describe the atmosphere?
I would say really an intense concentration. You're in the hands of the synchronized sequence. The 2 routines are running. Everything's going well, but a lot of things can happen. You follow up all the steps to be sure everything's going well, and you cross them out one by one as they go through. So I'd say people are calm, they're confident, but it's always an intense moment.
A minute and a half to go. You'll see shortly the invited guest here will rise and go out to the terraces. There are terraces on either side here of Jupiter Mission Control with fine view of the launch base, which is, as Luca mentioned, is 13, 14 kilometers away from us here. The DDO is going to call out the 1 minute mark.
DDO, attention pour H0 moins 1 minute. Top H0 moins 1 minute.
So the DDO has called out the -1 minute. Here we go. We're getting into the final ignition sequence. Very close.
Now describe the ignition sequence for us. What do we watch for?
Well, this evening we're not flying in Ariane 5 ECA, but an ES, so we won't see the retraction of the cryogenic arms because they're not used. But what we will see will be the ignitions of the Vulcan 2 hydrogen cooling gas igniters at around -5 seconds. That's at the base of the thruster of the Vulcan 2.
Let me just stop you because you mentioned the cryo arms. Those are those yellow bars there that are folded that you can see right in the middle of the screen.
Exactly.
Normally they're feeding the upper stage. Tonight they're not because we're not using that version.
Then a zero ignition of the Vulcan 2 followed by verifications and liftoff with ignition of ESAs.
Attention pour le décollage. 10, 9, 8, 7, 6, 5, 4, 3, 2, unité, top, allumage Vulcain. Allumage confirmé. Top, allumage EAP, décollage. Tous les paramètres à bord sont nominaux.
Well, we lost her to the low clouds early, but in a blaze of light, there she is, coming back out of the clouds, roaring off the pad. The DDO says everything is normal, propulsion and trajectory. In a blaze of light and a trail of gold as Ariane 5 reaches into the skies above French Guiana, on her way to deliver ATV-3, which will make her way to the International Space Station next week.
We've lost her through the clouds. So the launch vehicle first clears the pad in a vertical rise. And you can start hearing the noise. And the launch vehicle has just passed Mach 1. It's past the speed of sound. 6 kilometers in altitude, 317 meters per second.
773 tons at liftoff. She's burning 5 tons of fuel every second, 2.5 tons in each booster. Those are the big flames on either side. And the EPC, the core stage, in the center is burning another 300 kilos per second. Ariane, following the program in the onboard computer, which gives all the orders, including stage separation, which we will soon see, because the boosters and the first stage are burning now, and the boosters will burn another maybe 20 seconds and then get the order from the onboard computer.
In all, they will burn for around 2 minutes, and they will deliver 90% of the thrust at liftoff.
Boosters burning their 240 tons in just over 2 minutes. You can see the 3 points of light there, the 2 on either side. If they come back, it looks like we lost her to the clouds again. 2 on either side are the boosters. Luca, on the left, on the upper left of the screen, there's a cursor, and on the bottom left, A and V.
That's right. A, the altitude. We are at 63 kilometers already, 2 minutes and 20 seconds, and we are at 67 kilometers from Earth.
Séparation des EAP.
And the DDO just called out the successful extinction and separation of the boosters. You see what that looks like? There's one on the other side out of camera range. Dropped right on time and on target. Before the boosters are empty, their push diminishes, and this is what the onboard computer senses, a drop in acceleration, and then it separates them. Separation occurs 1 second after the onboard computer has detected this speed loss. Did you mention the altitude and the speed?
Right, so V, the speed, as you can see, 2.24 kilometers per second, not per hour. And if we look at the curve is a projection of where it should be, and the dot is the actual position of the launch vehicle. So as long as the dot remains on the curve, everything is going very well.
So it's real time superimposed on optimal, a real trajectory superimposed on the optimal. Okay, we're waiting for the fairing jettison.
So the fairing is a 17 meter by 5. We've had separation of the fairing.
You can see how that happens. There are 2 halves, actually. The other is out of camera range on the other side. Blown away by what? A series of pyrotechnic cords, I think.
That's right. So it's actually a very light structure, although it is 2.4 tons. But it's 17 meters high, 5.4 meters wide. It's carbon fiber sandwich around aluminum honeycomb. And it protects the payload from the dense atmosphere as it goes through. Then once we get out of this dense atmosphere around 100 kilometers up, we don't need the fairing anymore. So we have a vertical separation system, a horizontal separation system, and they break the fairing in 2 at the separation.
We don't need it, it's just dead weight. Why not get rid of it? Back with more of the mission in a moment, but for now, the latest news from Arianespace. On February 13th, the European Space Agency successfully launched the first Vega vehicle from French Guiana, orbiting 2 scientific satellites and 7 small satellites for European universities. This historic mission now gives Europe a full family of launch vehicles and provides Arianespace with the world's widest range of commercial launch services.
At the World Space Risk Forum in Dubai in February, Arianespace
We also have a dry cargo installation and flight batteries, all the propellant filling. It all takes place in S5, not necessarily in that sequence.
The French Guiana site was chosen in 1964 among 14 possibilities, including Australia and Scandinavia, give you an idea of how far they were looking across the world. France wanted to build a new base. Why did they choose here? They found everything they were looking for. Number one, a large opening on the ocean to make flying both north and east for different orbits possible, and over an area that offers low risk to the population.
Yes, and as you mentioned, a low population density. Only 200,000 people or so live in French Guiana. Most of this nation, it's lush tropical Amazon forest.
Also, we're near the equator. We're 5 latitude north, I think, of the equator, which allows us a launch to benefit from what they call the sling effect. The Earth's rotation gets us more quickly into orbit.
Yes, the Earth's natural rotation. In fact, while being on the equator, we already have nearly half a kilometer per second of translational velocity. So the closer we get to the poles, this reduces to 0. So being here on the equator can be very beneficial, especially for our GTO missions.
Also, no hurricanes.
No hurricanes. No earthquakes, as they can strike other parts, particularly in the Caribbean.
They even found nearby hills where radar and telemetry facilities can be installed to easily follow the launcher during her trajectory. We'll be talking about that in just a moment. The invited guests and the VIPs here are going to be shortly, I believe, making their way out to the terraces. I see the monitors are standing by the doors, or maybe not tonight. Usually they go out and they can watch the launch from the terraces. There are 2 of them outside here in Jupiter. Ariane lifts off from the pad, as we mentioned, about 14 kilometers away and passes right over us in Jupiter as she makes her way east. We're coming up on the 1-minute mark. It will be into the final 60 seconds. You'll hear the DDO call out the 1-minute mark in just a moment. You can follow all the action on the website. Remember, Arianespace.com.
À tous de DDO, attention pour moins 1 minute.
DDO and the 1-minute mark coming up.
Top, H0 moins 1 minute.
And now the guests are getting up at the 1-minute mark. Usually they go out early. They go out at 2 minutes. We're in the final 60 seconds. Simon, all that's left to explain is the ignition sequence. What do we look for?
Well, at H0, the DDO will call out Allumage Vulcan, the main stage ignition. But at this moment, we don't lift off yet. In fact, there will be 7-second wait. For these 7 full seconds, the computers are checking the performance of this main engine as it's functioning and on the pad. If all is well, then, and only then, the order is given to light the 2 solid rocket boosters. At this point, there's no going back. We will be off.
We're off in a minute. We're going to cut away, let you hear the DDO, call out the final countdown. Enjoy the launch, everybody.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain. Allumage EAP, décollage. Tous les paramètres à bord sont nominaux.
And so we are underway. Did you see at 18:52 local time, and right on time, Ariane 5 began her mission, lifting off beautifully, showing a lot of power right from the ground here in French Guiana, with a lot of fire, beginning her 2nd mission of the year, the 20-ton ATV, going to the International Space Station. Beautiful shots, always impressive for the people at the observation sites around the base, in their cars or on the beaches. Ariane lifting off
in her trail of gold. She's making a turn now. She's going to pass overhead.
We're about 15 kilometers from a launch pad, and even here you can still feel the sensation of launch. But if you're watching from that closed viewing station, which is only 5 kilometers away, you can really experience that sensation of the acoustic noise from those 2 solid rocket boosters, as they provide right now 90% of a thrust, propelling the launch along its trajectory at ever higher velocity. It really is quite sensational to witness there in Toucan.
How many launches have you witnessed?
I've been fortunate to witness 2 from there, plus tonight from here.
777 tons is Ariane's weight at liftoff. The DDO is saying that everything is okay on board. She's burning, if you can believe it, 5 tons of fuel every second. 5 tons of fuel every second. 2.5 tons in each booster, plus the core stage, the lower stage, burning another 300 kilos per second. The launcher now following the program in the onboard computer, which gives all the orders, including stage separations, which we'll soon begin to see. We are in the first of 4 flight phases. We'll describe each in turn so you can follow Ariane. Right now, the first flight phase, the single Vulcan core stage burning with the boosters. The boosters are going to burn for another 4 or 5 seconds, and then they will be extinguished, and you'll see them probably, it looks like the extinction of the boosters. You can see them falling away on either side. The orange lights are the boosters flailing out, and the single point of light in the middle of your screen is Ariane continuing to burn.
Yes, the DDO has announced the separation of the 2 solid rocket boosters, and coming at a time at 65 kilometers in altitude.
Take a look, Simon, at the left side of your screen. On the upper left, you have the cursor crawling up a line. Below that, some letters and some numbers, A and V. Can you explain?
Yes, so looking at this screen, this is Ariane's trajectory. It's showing us how the flight is progressing. The curve, it's a computer simulation of the actual trajectory. And that white dot on the curve, this is the actual position of the launch vehicle right now.
There are actually 2 trajectories. One is the optimal trajectory and the real-time trajectory. As long as we're one on top of the other, we're right where we should be, right?
Exactly. Superimposed, perfect. So the V means velocity, and right now we are traveling at 2.4 kilometers per second. And the A, this is the altitude. So now we're at 106 kilometers already.
We're out of the Earth's atmosphere, or will be shortly, which means the fairing can be jettisoned. There it is, coming right on time at about 110 kilos. We're using a new fairing separation system tonight, aren't we?
That's right. And in the past few years, Arianespace in Switzerland, the Ariane 5 fairing manufacturer, they have been developing a new system to support the fairing separation event. In this new system, with the aid of pyrotechnics, the fairing first separates from the Ariane around its circular base.
Happens very, very quickly, doesn't it?
Very quickly indeed. 56 milliseconds to be precise. And during this time, the separation, it's aided by a series of very precisely tuned springs around the body of Ariane.
So at this point, we can say the fairing has been separated.
Only by a few millimeters, though. Then a command is sent to separate the fairing 2 halves. The whole event is over in less than 100 milliseconds.
Now, they wanted also a new design, a shock reduction system, a low shock.
Yes, exactly. The whole concept, this endeavors to minimize the shock environment transmitted to the Ariane's passengers. Today, it's the first mission of this system, so a special hello to the whole work team in Switzerland.
The new shock reduction system was 5 years in the making. The fairing separated first horizontally, then pushed up and away laterally. We're in the second powered flight phase, the single core engine burning. Simon, what's the role of the single core stage?
Well, the EPC, this is the main cryogenic stage, and it, for some details, it's 5.4 meters in diameter and it's 31 meters long. It's powered by one Vulcan 2 engine that burns liquid hydrogen and liquid oxygen. The Vulcan 2 engine provides up to 1,400,000 newtons of thrust in the vacuum of space, and its nozzle, it's gimbaled to provide pitch and yaw control for the Ariane vehicle.
We're doing fine on board, Ariane performing flawlessly. More of the mission in a moment, but for now, the latest news from Arianespace.
On May the 7th, the newest member of the Ariane family, Vega, flew successfully for the second time. On a sustainable development mission, Vega orbited 3 satellites: Probe V, which will carry out Earth observation for ESA, VinRedSat-1, an Earth observation satellite for Vietnam's Academy of Sciences, and EstCube-1, the first satellite ever launched for Estonia. This launch, 15 months after the successful first launch, validated Vega's systems to carry multiple payloads.
Arianespace in May held its annual Japan Week in Tokyo with satellite builders and operators from the Japanese space sector and meeting with customers Sky Perfect JSAT, BSAT, and the Japanese space agency JAXA. Arianespace opened offices in Japan in 1986 and now has 75% of the market share and is the preferred launch services provider for the nation's space industry. With Mitsubishi Heavy Industries, Arianespace has developed an innovative partnership offering launch services with Ariane 5 and the Japanese vehicle H-2A. Japan remains one of Arianespace's leading partners.
The journey has begun for O3B. The first 4 telecom satellites in the constellation are due to fly on the next Soyuz launch on June the 24th. Another 4 satellites will be launched later this year. O3B is a next-generation satellite network that combines the reach of satellite with the speed of fiber.
And at the same time, Arianespace is readying another Ariane 5 launcher for her mission. The 214th Ariane flight, set for July 25th, will place 2 communication satellites into orbit, AlphaSat for Inmarsat and INSAT-D for ISRO, the Indian Space Research Organization. Just under 2 minutes left in the lower stage burn. We've been picked up by our downrange tracking station in the Atlantic. That's a ship designed specifically for Ariane missions. Today Ariane is heading north across the Atlantic towards Santa Maria in the Azores, and then over and across parts of Russia, down to be followed and picked up by sites in Australia. We won't be here for the acquisition of Perth.
No, this comes at 2 hours and 24 minutes into the mission, but Ariane will be tracked by the others during this broadcast.
All of her trajectory has been designed to be followed from the ground, whether by land or by sea. The launcher sending radar and telemetry back, and the network of stations keep constant watch on her vital systems. What is telemetry, Simon?
Well, basically, the telemetry is the launch vehicle data that is being monitored, collected, and transmitted back to the ground stations. In fact, there are over 1,500 parameters to measure, all indicators of the Ariane's health and performance during flight.
1,500 parameters. What kind of parameters?
Well, parameters such as the tank pressure that confirms the nominal status of the propulsion. We've got gyro data that confirms the nominal orientation and attitude of a launch vehicle along its trajectory. There are also accelerometers, strain gauges, and temperature sensors throughout.
And they're supposed to record all of her functions?
Yes, motor ignitions, for example, stage separations, motor shutdowns, all aspects like this.
Now, some of this data is analyzed in real time, being analyzed right now, and others are analyzed after the flight.
Yes, this is how we validate how the vehicle has performed. So you can imagine the enormous archives of data which we've accumulated.
We're waiting for confirmation of the extinction of the lower stage burn. That should be coming up right now. There it is on the screen. We have often a couple of seconds delay as the telemetry comes in. There we have the DDO has confirmed the cutoff of the lower stage engine and the separation of the lower stage, and as you saw, the ignition of the upper stage. These are 3 commands given by the onboard computer in about 12 seconds. We're into the upper stage burn, the next powered flight phase. What's the role of the upper stage, would you say?
Well, we call this the EPS, and the EPS, it's a storable propellant upper stage. This is responsible for providing the additional final velocity needed to inject the payload, the ATV, onto its specified orbit. The EPS will now burn 5 tons of propellant for the next 490 seconds or so in this first burn.
490 seconds, roughly 8 minutes. Compare that with the Ariane 5, the ECA version, the other version?
Well, in the EPC, the previous stage, and also the ECA configuration, we were burning cryogenic propellants. In this EPS, we are burning monomethyl hydrazine and nitrogen tetroxide.
I couldn't pronounce that. No.
This is a storable, reliable propellant for this configuration. The fact that we were not burning cryogenic propellants on this upper stage, that's why maybe some of the viewers would have seen leading up to the launch, we did not need those visible yellow cryogenic arms on the upper part of the launch table.
We're choosing this configuration called the ES tonight because for this mission's particular needs, the EPS is the most efficient means to do the job. And we've used it before, right?
Yes, it's a configuration we've used previously on the other ATV missions, and we'll continue to use this on the Galileo missions due to fly on Ariane starting December 2014.
We had a look at the launch zone before liftoff. Our camera is going to go up now to the CVI, another center of action, the Immediate Visual Control Center. What's going on here?
Well, the CVI, this is a facility located south of CSG and up high on a hill with excellent exposure for all the range activities. And it comprises all the means for receiving, processing and storing all the telemetry we spoke about before. Right now there are a number of people following and analyzing all the key flight data, and they are in real-time contact, reporting the flight status directly to the team here in Mission Control. And remember, Mission Control is the nerve center that is in contact with all the needed facilities throughout the range.
Right, and all their information comes in here to the DDO, who calls out the results. There used to be, I think, a deferred visual control center used for Ariane 4, but they don't use it anymore. There are different propulsion systems on Ariane 5. Is it fair to say, Simon, cryogenics are more efficient than solids? Basically, correct me if I'm wrong, solids are for getting us off the ground, brute force, away from the pull of the Earth. Cryogenics, more sophisticated, used for precision orienting of a vehicle, and of course they're reignitable.
Yes, we could say this. And on this ES configuration, we started with the cryogenic main stage. 170 tons of liquid hydrogen, liquid oxygen, burnt for 540 seconds or so. In propulsive efficiency terms, it's the best.
But the boosters in the first flight phase, that's a whole different system. That's a solid system.
Yes, there were the two SRBs, 240 tons of solid propellant per booster. And they each burn 130 seconds or so. They each provide 7 million newtons worth of thrust during the early phase of this flight. That's 90% of the propulsive force. Then there's this the EPS upper stage we spoke about before. This has the responsibility for delivery of the ATV to the correct orbit on which the ATV can start its independent mission to the International Space Station.
In our next film, we're going to continue in our ongoing series highlighting the different professions here at the Space Base. Tonight, Ambra Pedrassini on her role as Fluid Systems Specialist.
My name is Ambra Pedrassini. I'm 27 and I've been working at Arianespace for a little more than a year. I studied engineering in Italy, in Milan. I came to France to work in the field of space and in a European framework. I started working for CNES and then joined Arianespace, where I'm in charge of fluid systems. During the launch campaign, I'm responsible for EPC special checks, that is, all the operations on the propulsion system of the main cryogenic stage. I'm responsible for the filling of the oxygen and hydrogen tanks, the flushing of the cryogenic stage, the pressurizations of the devices which help control the EPC controlled valves. What we're going to do now is a hydrometric check in the Vulcain engine, which along with the two solid boosters enables the rocket to take off. It's very important. It helps us make sure there is no moisture in the oxygen turbo pump of the Vulcain engine. The risk with moisture in the oxygen pump, which is hidden behind that thermal shield, is that when liquid oxygen flows through it, moisture freezes, and that could prevent the engine from operating properly. What we're going to do now is connect tooling to measure traces of hydrometry on this line in cooperation with our partner SNECMA. During operations, I must manage the operations, that is, coordinate what is done on the platform with what is done on the test bench. What I like about this job is the fact that I can work with very different people, colleagues from all over Europe and from industry as well. Everyone brings one's technical but mostly human contribution to that campaign. People have different histories, different cultures, and it makes it very interesting. Also, Arianespace has a whole range of launches. Even though I work on Ariane 5 today, I may one day work on Soyuz or Vega. And being Italian, I would love to do that, of course.
And we've now been picked up by our next downrange tracking station in Santa Maria in the Azores.
With 15 minutes into her flight, the ATV on the way to the ISS, where she'll rendezvous and dock during the night of June 15th. This was the same time period for ATV-2, which made the trip in about a week, as did the ATV-3, which went up last year. But not the case for the very first ATV, since she had to undergo a series of what they call docking days. A lot of tests and dry runs to make sure the new system was working properly. So a couple of weeks went by before the first ATV was ready to dock in 2008. But since then, it's been a quick trip up.
Yes, and all of the manoeuvres are followed very carefully by the team in a specially built ATV control center in Toulouse, southwest France. And towards the end of this broadcast, we'll be visiting the teams in this facility to learn about their role in following this sophisticated International Space Station cargo freighter and its operations.
And once the ATV has docked, it'll stay there for 6 months until the 11th of October. It's re-entry planned for the 15th. But in the meantime, what's it going to do for 6 months up there, Simon?
Well, it's Europe's contribution to the what we call the logistics servicing of the International Space Station. The ATV-4, like its predecessors, will be delivering cargo in a pressurized environment. It will also be delivering water, gas, and International Space Station propellant. It also provides an International Space Station reboost capability, a reboost to a higher orbit, even attitude control, and at the end of a mission, it will serve as a waste disposal.
Yeah, we'll talk about that in detail in a minute. We're coming up on extinction of the first upper stage burn, and you'll hear the DDO call out that milestone. There you can see the nozzle shutting off.
Première extinction de l'étage supérieur EPS sur commande de guidage.
And the DDO is just called out. We're now in a coasting phase, also called free flying. What's happening?
Well, with the first burn of the EPS, we have now placed the configuration, that's the ATV and the EPS upper stage, on its correct path towards the separation orbit. And now, at this velocity of nearly 8 kilometers per second and at the altitude of 150 kilometers, we can simply leave a configuration in the driving hands of the laws of physics.
So we don't need any propulsion?
No propulsion required. We'll continue in this coast phase for the next 40 minutes or so.
Yeah.
Then we will ignite the EPS to place the ATV precisely in the correct orbit needed before separation.
After this phase, we'll have the second ignition of the upper stage. That's a short one, lasting just under half a minute. There'll be a third upper stage burn, but we won't see that. It'll come at about 2 hours and almost 2 hours and a half into the mission at an altitude of about 260 kilometers. We have a next film coming up. What are we going to see?
We're going to go to a series of launch replays now, and you can relive again those exciting moments as the Ariane left the pad nearly 20 minutes ago.
ATV powering off the ground, as you might recall. Those mighty engines, 5 tons of fuel burning per second, lifting her out of the atmosphere, away from the Earth's gravity. As she began her mission, that was just nearly 20 minutes ago. We'll have other replays coming up before the mission is over tonight. And you can see from different vantage points, there are a number of observation sites here across the space base. And we have our cameras set up in different areas. That was the booster separation. We don't often get to see that, Simon, with the naked eye, when the boosters can flame out.
No, that's very impressive of the people in the sites across the base here.
The ATV is bringing supplies, but it will also reboost the station. Now, you mentioned that. Now, last year, the ATV-3 reboosted ISS by some 40 kilometers.
It's now waiting patiently for liftoff.
Charlotte and I are now back in our commentary box. Charlotte's going to be joining me throughout the programme, and we'll be taking you through to separation of the ATV. So you can see the green status panels there on the right-hand side of your screen. All the different parts sending their status there. This is the Launch Control Centre. What's happening over here?
Yes, there are 3 teams in this Launch Control Center. One is led by the COL, Klaus Sell, And he deals with ground operations, and he liaises with the launch site operations manager. If all conditions are met, it is he that authorizes the start of the synchronized sequence. He is supported by a quality manager who was just in view. Then there's a second team that ensures the readiness of the launcher and is led by the CPAP. Tonight this is Didier Aubin. And he is also supported by a quality manager, which is Erika Velliou. So this is all kept under close control.
And this is often known as the bunker because it's in a very specially protected building only 3 kilometers from the pad in the launch zone, which is where what we're looking at right now. 2 minutes and 44 seconds to launch. This is the program director. Today it's Pierre-Yves Bertin. He coordinates between Arianespace and the European Space Agency. And this is the ATV desk. This is your gang, Charlotte.
Yes, this is our mission manager. It is his job to make sure all the various issues are resolved to get us here today. And he is supported by his deputy, Monsieur Siriguet. And next to them is the Astrium team, led by Gilles Debat and his deputy, Michael Teichfahrt. And here we have the launcher with the beautiful ESA logo. Here we have the LBC. This is where the technical teams are located right now. It's an ESA and Astrium team, mainly an Astrium team, of course. And they are looking at the telemetry that is coming from ATV via equipment in the launch table. And this allows us to keep an eye on what's happening inside the ATV. They are monitoring things like pressure, temperature, water control system, the pressure inside the cargo part, etc.
And we're coming up to, here we are, 1:35 now to launch. A quick word about the launch sequence. On Ariane 5, we have a 7-second delay between ignition and liftoff. That's because we start the Vulcan engine first and wait for 7 seconds to check it's working before we ignite the boosters. We're now waiting for the range operations manager to announce the 1 minute to launch moment.
À tous de DDO, attention pour moins 1 minute.
We are 1 minute to launch. Switching to onboard.
À 0 moins 1 minute.
Switching to onboard power. We are live at the Guyana Space Center for the launch of ATV-5 Georges Lemaitre for the European Space Agency, built by Airbus Defence and Space. Our very best wishes to our customers and to everybody who has worked so hard to bring us to today's launch.
À tous de DDO, attention pour le décompte final. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage Vulcain, allumage des 2 EAP et décollage. Tous les paramètres à bord sont normaux. Tous les paramètres à bord sont normaux, la propulsion est nominale.
And we're off. Ariane 5. Powering out into the night sky here at the Guyana Space Center. That streak of gold coming from those 2 powerful boosters. Just catching the sound of that now here, 15 kilometers from the pad as she flies over. And ATV Georges Lemaitre is on its way. Destination, our human outpost in space, the International Space Station. People in the viewing stations will have felt the ground shake. I've sent Charlotte out to go and watch the launch in real life rather than on the screens here, so we'll wait to hear how she experienced it. Right now, the boosters are doing all the work. They're literally pushing us away from the Earth's gravity. That's what keeps us stuck to our planet. Makes it very difficult to leave as well. And we may get lucky and see those boosters falling away there with the naked eye. Each one is burning 2 tons of propellant. That's an awful lot of propellant per second. 2 tons per second. Just to give you an idea, if you filled your car once a week, that's just about the amount that you would be using in a year.
Séparation des étages d'accélération à poudre.
And we did see them separating there. Superb sight, the boosters falling away. And this, there we go, the 2 dots on either side and the white dot in the middle is the Vulcan engine that you can see, and those boosters falling back down. We're shedding weight. We don't need them anymore. We're losing each stage of the vehicle once it's burnt up its fuel, because of course the lighter we are, the faster we go. Right now we've lost about 3/4 of our weight in just over 2 minutes. So right now the main stage is doing all the work, and you can see its Vulcan engine there. That's the white dot in the middle, and still a dot of booster falling away to the left of the screen. Everything's going according to plan, he says. If you look at the bottom left, you can see our altitude is 106 kilometers above the Earth. We are at a distance of 232 kilometers if you were to draw a straight line, and our speed is 2.5 kilometers per second. We're now losing the fairing, and Charlotte has just come back into the commentary box, having seen her baby take off into space. How did you feel?
It's better if I turn the microphone on. That was quite something. It was absolutely spectacular, and I still got I got the blazing lights of the boosters in my eyes. It was fabulous.
You've got the retinal imprint.
Yes.
And what about the sound? And what about the...
Impressive. Absolutely impressive. No chance anybody in this area could miss that.
People quite frequently go to the beach to watch it. Charlotte, let's just tell everybody about the curve on the top right-hand side of the screen. What are we looking at here?
Yes. The green curve is the calculated curve, so this is the expected trajectory, and the yellow overlay is the actual trajectory as calculated from what we're getting from Ariane.
And if you look on the picture on the... He's saying everything's going well and according to plan. And on the right-hand side of the screen there in the middle, you can see the image. We can actually see ATV for the first time now. And these are computer-generated images that we're looking at, Charlotte.
Yes. We know what's happening, or we know what should be happening every minute and every second of the flight, but of course we have no cameras to show it to us. So we have this excellent animated view of what's going on up in space right now. And in parallel, the Ariane launcher is transmitting telemetry down to the telemetry stations here in French Guiana, and this includes the various mission events which are being reported by the DDO.
And here at the Guyana Space Centre, it's been a very busy time. We've already had 6 launches this year. Today's our 7th, and we're preparing more.
In a textbook launch on board the 8th Soyuz from French Guiana, Arianespace successfully orbited the next batch of satellites for O3B networks, a year after launching their first 4. O3B is offering high-speed, low-cost broadband from space for the other 3 billion people on Earth who presently have little access to internet. The senior VP of Arianespace, Switzerland, and chairman and CEO of Arianespace signed a contract for more than 100 million Swiss francs to deliver fairings for Ariane 5 till 2019. And Ariane 5 is being readied to carry the Measat 3B and Optus 10 satellites into orbit in September. Preparations in the Vehicle Integration Building are now finished. Soyuz is being readied for an August launch of the first 2 fully operational satellites in Europe's positioning system Galileo, with 2 more planned by the end of the year. And the various parts of Vega have arrived in French Guiana and were transferred to the Zafiro Preparation Building, ready to assemble the launcher for its 4th flight. It'll orbit an experimental vehicle for ESA to test vehicle re-entry into Earth's atmosphere.
So we're looking at the main stage there, and on the left you can see ATV attached. We're tracking the launcher using ground stations as she flies over. It's called telemetry, and we're going to be picking up the signal shortly at SNA, which is a boat in the Atlantic. Tell us a bit more about telemetry, Charlotte.
Well, the launcher has computer systems on board that are collecting all the essential parameters. And a subset of this is being analyzed in real time as it comes down via the telemetry ground stations. And this is the data that is used to immediately assess the performance of the launcher. And this includes also the reporting of the events I mentioned earlier. So this allows us to, or the launch team, to know what's going on.
And our flight path tonight takes us out across the Atlantic. And we are travelling northeast across the Atlantic, heading towards Paris. We'll then travel across northern Europe, down across India, Indonesia, and down towards Australia, where we will start the process of separating ATV. Which ground stations are we using?
The ground stations that are being used for this particular flight start with Galileo here in French Guiana, the boat that we have spoken about earlier, Station Navale Ariane.
Tous les paramètres à bord sont normaux, la propulsion est nominale.
And then next in line will be Santa Maria in the Azores. And after that, it will be handed over to the radar in Brittany, after which it will be in the visibility of Azaguel near Toulouse. Then there will be a gap in telemetry, because there's no station within visibility, and this will last roughly 45 minutes, after which it will be picked up by Adelaide.
So the main stage has now switched off its engine, it's falling away, and we are igniting the engine on the upper stage, and this is a crucial part in the flight.
Séparation de l'étage, allumage de l'étage à propergol stockable.
Yes, there was the announcement.
We have the announcement, thank you. So we're now burning the upper stage. Its job is to deliver ATV-5 to its separation orbit. That's 260 kilometers above the Earth.
Les paramètres à bord sont normaux. Fin du rattrapage suite à la séparation.
And after that, ATV will climb on its own to the ISS. That's around about 420 kilometers. Charlotte, we're going to be reigniting our engine several times tonight, aren't we?
Yes. And the reason for this is that for the ATV we are targeting a circular orbit, 260 by 260 kilometers. And therefore it needs to be reignited one more time later during the mission here. And then there will actually be a third ignition of the upper stage in order to deorbit it safely. But this takes place only after the separation of ATV.
And we're using a storable propellant upper stage, which is why you didn't see the cryogenic arms during the launch. Often we use the cryogenic upper stage.
Yeah.
So here's a replay, Charlotte, of the launch that you saw earlier when you went outside to watch. Ariane taking off into the night sky.
It was absolutely brilliant. It lit up the entire sky. It was quite amazing to see it.
And it makes the night sky look like daytime, doesn't it, when it takes off, because the light is so tremendous.
Yeah, well, certainly stayed on my retina, as you said. And here it comes again. I think this video is going to be watched quite a few times in the coming weeks and months. It's really a credit to the Arianespace teams.
And of course, with the support of Guyane Premiere, the television crews here in French Guiana. That was 11 minutes and 9 seconds ago. Countdown on the top right-hand side of your screen there. So we've been meeting the teams at the Guyana Space Centre. There's another team involved in the launch right now. Of course, it's the ATV CC, the people in Toulouse. What are they doing right now?
Well, the first teams came on console about 16 hours before liftoff.
La pression dans le réservoir est conforme à l'attendu. Le pilotage est calme. Tous les paramètres à bord sont normaux.
And at the moment, we have no telemetry from the ATV because the receivers are off. But they have established the communication links which are necessary in order to get the telemetry to Toulouse once it has been separated from the Ariane. And this involves the TETRAS satellites. These are NASA satellites orbiting the Earth.
And once it docks, ATV will have several different tasks.
After final preparations at Europe's spaceport in Kourou, ESA's latest ATV is bound for the International Space Station, the ISS. With already 4 successful ATV missions, this 5th vehicle marks the end of an era, since it is the last ATV ever built. ATV-5 has been named Georges Lemaitre, as a tribute to the Belgian priest and scientist who is considered as being the father of the Big Bang Theory. It will once more be used as a supply vehicle to the ISS and will be the heaviest spacecraft ever launched by the European Space Agency.
We have, of course, as for any ATV, a different cargo composition compared to the previous missions. And the peculiarity, which we are also proud of for this last mission, is that for the first time we will have the full load of potable water, about 850 kilograms, to be uploaded for the benefit of the SS crew.
ATV-5's dry cargo load is over 2.6 tons, with over 1.1 tons loaded into the ATV during the so-called late cargo access operation, when the ATV is already mounted on top of the Ariane 5 launcher. This 1,100 kilograms is more than double the late cargo load of the previous ATV load. Besides the usual supplies and scientific cargo, ATV-5 will also be embarking a new laser system for supporting approaches and docking to any target. An experiment based on new sensors.
ATV-5 has something very special on board, which is called the LIRIS experiment. It's a suite of optical sensors which are discoupled from the ATV functionality. They are just registering data during the approach to the ISS, and they are meant to allow technology advancement in the area of sensors with the final objective to later on maybe dock or rendezvous to non-cooperative targets.
Once the ATV-5 is in space, it will rendezvous with the ISS using its sophisticated guiding system. Upon its approach to the ISS, the ATV's automated docking system will be activated and the Georges Lemaitre will dock to the ISS. The operation will be supervised from inside the ISS by ESA astronaut Alexander Guest.
ATV-5 will be attached for 6 months at the International Space Station. During that time, it will provide the altitude and attitude control to the ISS. And when all the dry cargo has been removed from the cargo carrier, it will be filled step by step with trash cargo. And after the 6 months, it will undock from the station and will do its controlled destructive re-entry over the South Pacific uninhabited area.
With ATV-5's re-entry happening at a less steep angle this time, it provides an opportunity to more fully understand the behavior of the spacecraft. This will be monitored both from the ground and from the ISS, gathering important data for the future destructive re-entry of the ISS itself. This last ATV dive will mark the completion of the ATV program. After 20 years of work on the ATV, ESA will put its investment to good use for future endeavors.
Running a program with 5 flawless ATV missions is an achievement we can be very proud of. The good thing about it, it's not a real land. we are going ahead with a service module which we still consider as a derivative of ATV. In that sense, there is a perspective.
In the near future, ESA will take part in the NASA Orion program by building the service module of this manned capsule mission using the ATV module as a basis. And the automatic rendezvous technology will be key for future space exploration missions.
Very exciting technology there. It gives you goosebumps. And you can see on the top right-hand side of the screen, we climbed high into space. We've plateaued out, heading towards our orbit. We've had acquisition of signal at the base in Santa Maria in the Azores. We are heading out across the Atlantic now towards Africa. How different is the cargo on board Georges Lemaitre, Charlotte, compared to some of the other ships?
Each ATV has had a different cargo configuration. And about the only thing that is constant between all five has been... That's the end of the first boost.
The end of the first boost of the upper stage, which has switched off its engine. And we are now entering what we call the ballistic phase. That means no propulsion. We've switched off our engine, so we are travelling under our own steam. Why is that, Charlotte?
Well, basically, we are now pursuing the trajectory caused by the first boost, and we are waiting for the right moment to perform the second boost, which will put us on the circular orbit, which is our separation point.
And this ballistic phase, or coast phase, is going to last about 45 minutes, and then we'll switch our engine back on again. The International Space Station is huge. It's about the size of a football pitch. Way too big, of course, to launch it in one piece, so it has to be assembled in space.
Yes, you could see the ISS in a way as a giant Lego. The first piece came up in December 1998. And the next piece came up just a few short months thereafter, and the teams have been building upon it ever since. And it has been evolving with each assembly flight, and of course many of the assembly flights were based on the shuttle because it was the only vehicle that could lift it up.
And ATV and the ISS are only part of the European Space Agency's remit.
Launched from the Guyana Space Center in 2004 on an Ariane 5, ESA's comet-chasing spacecraft Rosetta is now only a few days from its destination after a 10-year voyage across the solar system. Due to rendezvous with comet Churyumov-Gerasimenko on the 6th of August, it will fly alongside it, studying its nucleus and tail, having activated its 21 instruments on board since Rosetta woke up from deep space hibernation in January. Scientists believe comets might have brought life to Earth, and Rosetta will send back vital data helping us to understand our origins, as well as doing what no spacecraft has ever done before, orbiting the comet. These complex manoeuvres will last a year, during which time Rosetta will also look for the optimal landing place and send down its Philae lander in November 2014. Although it's now switched off, ESA's Planck Space Telescope is still offering valuable data since its launch on Ariane 5 in 2005.